bit, right?
I recorded and I decided to stop and restart now.
Yeah. Mhm. There he is.
At some point, I need to test the screen sharing.
Okay. Oh, yeah, you should have access to screen sharing.
I think I'm going to have to play games to do that. Okay, let's see.
Well, that should be straightforward.
Well, it's not quite as easy as I thought.
Mhm.
Let me see.
Walk me through the steps that you believe you're using.
Let's see, maybe I can,
I'm puzzled. Oh, wait, now I may be able to.
okay.
Let me try again. Yes.
That's the trouble with Quakers, they're insufferably helpful. Hey, there we go, the multiverse.
Okay, there's you. Oh, and here comes David.
Hey, David.
Hi, everyone. Ah,
So, David, we have Yeshua Ben David on the call
welcome.
from New Zealand. It's 1:30 in the morning.
Oh, goodness.
And David Clement is.
If you hear background conversations, I'm in another Zoom meeting.
Nice to meet you, David.
Nice to meet you.
Ooh.
Yeah. Joshua Ben David would be Joshua Davis in English. Son.
Oh, okay.
From my mom's side, I'm Joshua Ben David. From my dad's side, who is American, I'm Joshua Davis.
Whereabouts in New Zealand are you?
I'm in Auckland at the moment and basically doing some research that is very connected to what Paul is doing. Actually, he inspired that research. And in quantum physics, and after that, tomorrow I'll be going to the Coromandel Peninsula, which is where I usually exist, apart from when I come to the city to the lab.
I spent a bit of time. I'm originally from Australia, so I'm in New
I have a
Zealand.
question.
Oh, nice to hear that. And where from Australia are you?
Some, I don't know if you know it, basically on the coast between Sydney and Brisbane. So a
That
small
would be
town.
Newcastle.
North of Newcastle, about 400 kilometers north of Newcastle, but yeah.
Coffs Harbour is
Yes.
north, yeah.
Yeah.
That's
So
where
I
you're
went to
from?
high school in
Coffs
Coffs Harbour. Yeah.
There you go.
Yeah.
So you probably know about
I've been,
Oh, yes. Yeah.
Okay, so I'll check back with you later. Just I got people from New Zealand asking about me.
Okay. Just let Rob finish up.
No, I appreciate your.
Oh, dear.
Rob, nice to meet you.
Yeah, he's on the call.
Yeah. So while we're still not organized but relevant, Queensland is worthy of mention here.
Okay.
Extra mention. I've seen a lot of people in Washington talk about quantum technology. Just this week, there was this huge Zoom from the Secretary of the Navy and the President's office, all talking about what is this quantum technology and what is this AI? What is the future of the world? And of course, they don't know about quantum technology. And what I tell them is, in the United States, we are basically working very hard to develop one type of quantum technology, which is the quantum Turing machine, which is on this slide. Okay, on this slide, this guy, David Deutsch, was the inventor of the quantum Turing machine. His papers are the foundation of everything we're putting money into in the United States. But that was only the first generation. And beyond that, there's some more advanced quantum technology, some in Canada and some in China the Canada and China technologies are very important. But to really develop the best technology, you have to know what you're doing. You actually have to understand the physics, the reality. And the best understanding of quantum reality in the world today, so far as I know, is from quantum optics. Quantum optics is that branch of modern physics which really probes experimentally the real frontiers of how things work. And the most sophisticated mathematics in the world for the most advanced quantum optics is basically in two places, Queensland and New Zealand, both represented on this Zoom. Now, I suspect Yeshua can represent New Zealand a little more completely than David can represent Queensland right now. But those are the two places. I tell them there's a book from Queensland and a book from New Zealand. Those are the two books you have to read if you really want to know what's really going on in quantum optics.
From your laptop?
So Rob, I think you need to mute.
Oh, sorry guys, sorry.
Hello.
That's fine. Sorry.
What two books are those, Paul?
Okay, so from Queensland, Walls and Milburn, Introduction to Quantum Optics. And from New Zealand, Carmichael has 2 or 3 volumes in his series on quantum optics. The Queensland book by Walls and Milburn is easier to understand, but that doesn't mean it's easy. I can still remember when I struggled with it, learning to understand new concepts after I thought I had a PhD from Harvard, after my PhD thesis advisor won the Nobel Prize for the most advanced quantum theory that normal physicists know about. His name was Julian Schwinger. And I thought as a student of Julian Schwinger, I really knew quantum theory. And then a very important guy named Howard Grant, who was the brains behind the US government funding of quantum information technology. Howard Grant said, if you want to know what's really going on in this field, these are the 2 books you must read. Walls and Milburn to start, and then Carmichael when you're more sophisticated. And Yeshua is working with Carmichael's group.
Oh, okay. Cool. Very cool.
Yeah.
So do we have quorum? Shall we kind of jump in?
Sure, go for it.
Yes. Yeah, Paul, why don't you launch us off?
So first of all, I got to thank Rob for asking the question that generated this. Does anybody care about reality? Does anybody know about reality? And it's depressing to me to ask how many people care about reality anymore. That is very, very depressing to me. I may well be the last person on Earth who really understands the current quantum field theories and also believes in objective reality. At least I'm not the last one who believes in objective reality, but I'm the last one who believes in the hardcore version of realism, symbolized by Albert Einstein here. So on this slide summarizes everything we could talk about today. In fact, this slide would be worth a year of explanation. I put a lot in this one slide. On the upper left is Albert Einstein. And he represents a view of reality and life, which I call hardcore Einstein realism. And my next slide is to define more precisely what it is. My wife, Luda, says you need to explain none of these people are bullshitters. There's actually real math and even useful math in every one of these. But how do you come up with one equation to represent Einstein's view of reality? Most people would say E equals mc squared, but that's just one of his many equations. If I have to pick one equation, this is the one I picked for today, and I'll explain more why. And I do have more slides on Einstein. But on the upper right is David Deutsch. And if we lived in an honest, truth-seeking world, if we really believed in science as much as Joe Biden says we should, if we really believed in science, we would all recognize this face on the upper right. This guy is David Deutsch, alive today in Oxford, and he has two major things that we need to know about. Everybody should know about. One of them is the quantum Turing machine, and one of them is a theory of how the universe works. This is a theory of everything. David Deutsch is the leading expounder on planet Earth of a mathematically solid, complete theory of how everything works in this cosmos, backed up by strong empirical physics. Okay? We all should know about reality. This is the best notion of reality that modern physics has today. I still believe Einstein's is better, to be honest. Okay? So half my story, it could be the whole time. What is the connection between these two theories of reality? This guy, in a way, is building on this guy. These two have theories of the foundations of reality. They have theories about how the universe works at the most fundamental level. Maybe I should have even put these guys on the bottom, because these are the foundation, the laws of the universe as a dynamical system. How does our universe work? What are the dynamic laws from which everything else is just a consequence? Einstein and David Deutsch have theories of how everything works at the bottom, from which everything else is a consequence. And they have lots of empirical data. Of course, there are lots of physicists who will say, no, I have a theory, I have a theory. In most cases, those are just special theories of special cases. They all build on this concept or on this concept. These are the two fundamental concepts of how the universe works. However, when we talk about reality, we aren't just talking about the foundations. Even Aristotle made a distinction. There is the substance underneath, and then there are the forms and the patterns which evolve on top. There is a branch of mathematics called nonlinear dynamical systems theory. We did invite Robert Kozma to come here. I was halfway hoping he would come. Robert Kozma has collaborated with Yeshua and me.
I am here actually later.
Oh, wow.
I just got a late link, but I'm here. Okay.
I was
Nice
just
to
about
see
to
you.
say how important and great you are and how happy we are to have had some chance to collaborate with you. So, well, it's a good place to pick up. So yeah, these two guys on top are the best experts we have on what kind of a dynamical system are we living in this universe. But then there is this important branch of mathematics. I'm so glad you called when I mentioned it. There is this very important branch of mathematics, which Robert represents and von Neumann represents, and even I work in somewhat, okay? Which is not nonlinear dynamical system mathematics. This is the mathematics that makes the connection between the underlying dynamical laws which govern a system and the emergent behavior or properties which come out of that system. And so to develop an integrated understanding of the universe, there are basically two parts to it. What are the foundations? What is the dynamical system we're living in? And how does the mathematics tell us? How does it give us a chain of approximations, of connections that help us understand the emergent behavior which comes from these dynamical systems? In my life, I've tried to follow the work of this guy on the lower left, John von Neumann. I think Robert is also a follower of John von Neumann. There was a lot to follow. Robert and I followed several of the many things John von Neumann did. Many, many things. John von Neumann is known to some people as the first rigorous definer of what is quantum field theory. So I know people who would say, wait a minute, this guy David Deutsch, he wasn't just following Einstein, he was following von Neumann more than he was following Einstein. And this equation I showed here, psi dot equals IH psi. David Deutsch claims that this equation is the dynamical law of our universe. This is the best understanding we have today from modern physics of how our universe works. It's this equation. But he learned to use the equation. So far as I know, the first time I ever saw this equation was in the work of von Neumann. And von Neumann became famous when he was younger because of papers he wrote to explain the basics of this kind of quantum mechanics. And it's funny because he wrote this equation before anyone had the data to know the modern meaning. Everybody uses this equation in modern quantum field theory. But at the time of von Neumann, people would say, you don't even know what this equation means. But von Neumann was very important to understanding this equation. But von Neumann was also very important for some other pieces of work we should know about. Von Neumann, okay.
A quick question. Where does the satellite communications work of the Chinese fit in this framework?
The Chinese, obviously China is a big country. So there are many different things. Several elements of the Chinese work. But on this slide, I'm reminded of a great Chinese scientist. In an ideal world, I would show you his face, Pan Jianwei. And there are many people who say, if we do not know Pan Jianwei's face and name, that's just as bad as not knowing any of these faces or names, because Pan Jianwei really would belong on this level of science. Pan Jianwei is the person who brought modern quantum technology to China. And it's a long story. He's a friend. To be honest, one of his sons is probably one of my Facebook friends. I was pretty excited when he made the connection this year. Pan Jianwei went to the head of China, Xi Jinping, and explained to Xi Jinping himself what he learned in Austria from working with the professor Zeilinger, who is one of, and immediately, yes, you see Yeshua shakes his head because he knows in the world of quantum optics, everybody knows who Zeilinger is, okay? Some people would say Zeilinger is more highly ranked than Carmichael even or Queensland because he does practical systems and all the engineers say, Zeilinger builds it. Zeilinger built a project jointly with Pan Jianwei, who then brought it back to China, and they have a whole lot of quantum optics in China. And that's probably as much as I should say right now, because I want to get back to the main subject. But yes, China has a lot of capabilities in quantum optics, which go far beyond Deutsch's quantum Turing machine. Pan Jianwei knows things that these people do not know about. And that's part of why China has more advanced technology than any of our decision makers in Washington are accounting for or knowing about. But they shouldn't give up because we have Yeshua and we have Queensland. And if we learn to appreciate them and work with them, they have stuff even more advanced than what the Chinese have. But we got to learn to appreciate Yeshua and Queensland and Carmichael, because that's what points to a much more powerful quantum technology in the future. So should I go back to von Neumann? Okay. This is like magic. I mention a name or a concept and somebody pops up related to that concept. So Dave, yes, we were just finished talking about Chinese quantum technology, which goes beyond the quantum Turing machine. And I said, we need to move on to some more advanced mathematical concepts. And immediately you shut up. And I was starting to talk about John von Neumann. I said some things before about von Neumann, about he is the guy who first wrote this equation up here on the right, which David Deutsch has been using. I'm sure it came back to something from Heisenberg, but von Neumann's papers long ago, von Neumann way back at the time of Heisenberg, von Neumann was writing the papers which explain what this equation really means. Von Neumann's early writings, even from the 20s, are more advanced than a lot of the papers which appear today. So he knows something about quantum mechanics, but that wasn't the main work for von Neumann. To make these connections, to connect from fundamental physics to our lives, von Neumann said, there are three great questions in real life where we need fundamental new applied mathematics. Fundamental mathematics focused on three fundamental questions which are universal, where mathematical thinking is the key to integrated, coherent, meaningful thought. And those three big questions, von Neumann was very clear. We will have a real applied mathematics world if we develop a culture that can focus well on three basic questions in mathematics, which connect to the rest of life. One of them is, what are the fundamental laws of physics? So he knows about these guys up here. But the other two questions are, what is life and what is mind? How does the phenomenon we call life emerge as part of the behavior of a dynamical system? Some people say, oh, it's Darwinian evolution. Well, damn it, Darwinian evolution is an approximate description of the thermodynamics of a whole bunch of molecules. Can't we do better than a bunch of words? Can we come up with a mathematical understanding of evolution and life, which is more precise, more general, and more useful than just the words we started with from Darwin? Darwin gave us a great start in words. Newton gave us a great start, but we have to build higher to really understand it. We have to build the mathematics of how life and mind can emerge and can be built on a mathematical foundation. Now, to be honest, von Neumann did more than that. By the way, this equation under here, it's just one of the many equations he worked with. I mean, there's so many equations for von Neumann, it's almost impossible. How do you symbolize his work with one equation? But this happens to be one of the equations from thermodynamics, which is part of this. What is life? What is mind? But von Neumann also, of course, is known as the developer of game theory. In fact, I often tell people my Bible, if I had to pick one book to be my Bible, it would be John von Neumann, Theory of Games and Economic Behavior. People wonder, why is that your Bible? Well, I don't want to get into that too far because that's emerging at another level. But a lot of what the theory of games is about is, okay, we got life, we got minds. Now what are they going to do at a higher level? You got a whole bunch of minds and a whole bunch of life. How do you learn to cooperate? How do you work together? How do you help the civilization you're part of? And I have been very interested in that part of his work too. So these were all important parts of his work. The mathematics of life, the mathematics of mind, and organization, social behavior. In fact, I need to say one more thing about von Neumann because he was so important. Von Neumann was the father of a strain of mathematics called neural network mathematics. And I know some psychologists and some soft people who would say, no, it wasn't von Neumann. It was Hebb. Donald Hebb was the real founder of the neural network field. But it turns out that's not true. Hebb was one of the founders, really. And von Neumann was one of the founders. And when I give a talk on history, I say, well, von Neumann was the grandfather of neural networks on its father's side, and Hebb was the grandfather on its mother's side. And if you knew neural nets, you'd say, oh, and I'm calling Steve Grossberg the mother already. Well, maybe in a way he was, and maybe I was the father, because I took some key ideas of von Neumann about neural networks and translated them into real working systems which we use today, which were the basis of the cognitive revolution. For me, the AI what they call the new AI. They keep changing the names every week. For me, well, these guys had a lot of equations. I have a lot of equations. This one here is the equation people know best. They know it because it was done 50 years ago and people haven't kept up with modern times. This is the equation of backpropagation. And if you go to Google Scholar, you'll see this is what is most cited of my work. It's embarrassing that people know what I did 50 years ago and don't know the important big discoveries built on this. But this one equation is what we use as a foundation to build intelligent learning optimization systems, which fulfill John von Neumann's vision of what is mind. John von Neumann's vision of intelligent systems and neural nets. He was thinking about complex intelligent systems which learn to maximize utility functions over time. John von Neumann was the inventor of the concept of cardinal utility function. There's a thing called dynamic programming, which came from one of von Neumann's friends who had a daughter. We've had great conversations. These are all people who talk to each other. John von Neumann's friend Bellman had a daughter, Christy Bellman, who is still working in this field today. And they're all figuring out, how can you maximize a utility function over time? How do living systems learn to be born with goals and values? And how do they learn to maximize their values over time? How do they learn to be sensitive to whether the world is consistent with their basic values? And how do they learn to take actions? That's what intelligent systems are all about. The mathematics of how to build those intelligent systems is now called RLADP, recent reinforcement learning or approximate dynamic programming. I have to tell you my review of RLADP. It's in the current Encyclopedia of Control and Systems. So far as I know, it's the best overview of that entire field of mathematics. But there's also a book out there from IEEE, Handbook of Reinforcement Learning and Approximate Dynamic Programming. Bottom line is, we have a lot of mathematics which fulfills von Neumann's vision, and it relates to models of the brain. And Yeshua and I have looked at data on the brain to show that this fits empirically to explain how brains work. We have more work to do. That's just a beginning, but it's a pretty good beginning. The paper by Davis and Werbos is still the best source we have to start from to understand, how do brains achieve purpose? How do brains learn over time to be successful? And there are a lot of people working in neuroscience. They'll tell you how the chemicals work. They'll tell you what drugs to take, but they won't tell you how brains achieve intelligence. If you want to know how can brains achieve intelligence, the paper by Werbos and Davis is still the best starting point, unfortunately, because we need more work, but it is still the best starting point. And it is all based on what we learned coming from the strain from von Neumann. So this one equation is kind of important. And as you can tell, I got a few other equations for RLADP, lots of equations to make that work. And then the last thing I should talk about on this slide is that picture on the lower right. And what that lower right symbolizes is my view of some specific emergent phenomena. Beyond life and consciousness, there are higher order social organization, and there is also what we see in our cosmos if we look further. And if we look further, my experience and life tells me, if we look further, we see brains, we see humans, but we see a cosmos which is full of life. And my personal belief is that we really do have what people called a soul. And I definitely see how the mathematics, which we developed here, builds up to emergent phenomena. The mathematics we learned at that level and at this level provides a basis for understanding this higher level to better understand how we connect to our soul. And I know we have a problem in this world. People who believe in science and people who believe in the soul tend to fight each other. That's a real big problem. We even have problems with Chinese and Americans fighting each other, and Republicans and Democrats. In fact, there's so much fighting going on in this world. Our survival is threatened. This is not a game. There's so much fighting going on because of incompatible, inconsistent ideas. And that's what leads me to the bottom line on this slide. This is my new old saying, which I repeat again and again this year. This relates to the kind of stuff Doug Neal has been talking about. We all remember Hamlet, to be or not to be. That's the question. Will we live? Will we die? My version, to integrate or to disintegrate. Those are our real choices here and now on Earth. If all we have are wars between ideas that don't like each other, my prediction is those wars are enough to kill us. I know enough science, physics, and technology to know if we don't learn to integrate, we will die. So the challenge is to integrate. And when you look at this slide, you see 4 or 5 levels of understanding. To unify our thinking and achieve peace, to unify our thinking, to achieve peace, to be capable of working together, we need to integrate our ideas at a deep level. And to integrate our ideas, there is an understanding at all these levels which fits the idea of physics and the idea of the soul are totally in harmony with each other. Understanding physics helps you understand the soul if you are totally open to the soul. And understanding and responding to the soul helps you better understand the physics, as Yeshua could tell you. In the very beginning of this discussion, Yeshua was saying he's made the progression from the soul to the hardcore physics, and it works in both directions. We need to integrate. So it's hard to integrate such complicated things. We could talk about this big picture, but I also have some slides on this one little piece of it, Einstein realism. So I leave it to you. Should I move on to explain Einstein back down to the level of a really hardcore objective reality? Or should we discuss a little bit some of the other aspects first?
I'd be interested in hearing more about Einstein.
Okay. So next up, Einstein. That's if I know enough. Ah, yes, good. Okay, hardcore Einstein realism. Let me call it HCER. Let me emphasize, this is my definition. Einstein led a long life. Nobody agrees with everything Einstein ever said. You couldn't agree with everything he ever said. He said many different things. So as a good mathematician, I want to start by defining terms. I believe now in hardcore Einsteinian realism, HCER. This may be the first time I have made a sentence of the form I believe since I was a kid. It amazes me. Mostly I am uncertain. Mostly I think of n possibilities. But at this moment, based on all of the evidence that I now have access to, I actually believe in hardcore Einsteinian realism. It's not a religion. The minute I see an alternative, I'll look at it. I've been looking for alternatives. I've looked very hard for alternatives, but right now I see no evidence whatsoever to contradict this theory of reality, which I will call hardcore Einstein realism. This is my definition of what HCR means, his core idea. And I'll start on this slide with some qualitative principles. Einstein would first say, everything we know, except for pure mathematics, comes from what we see, feel, or otherwise directly observe from the movements of our universe, which is the same as our cosmos, which is the same as our space-time continuum. Objective reality. We live in an objective reality. And that objective reality is a space-time continuum. We can call it our cosmos. We can call it our universe. It is all of these things in one. Furthermore, according to HCR, our universe has 4 dimensions, which we sometimes call X, Y, Z, and T, time and 3 spatial coordinates. That's what they tell you in early grades. Then as you get to graduate, we just give them different names. These are just still 4 numbers, just different names for the same numbers. In algebra, you can pick any name you want, but sometimes a different name makes it easier for you to move on. So in modern Einsteinian physics, we call these 4 dimensions x0, x1, x2, and x3. And x0 sort of represents time. The first important principle of Einstein from special relativity is the underlying laws of physics look the same when you pick a different coordinate axis. If you change the coordinate axis according to what they call a Lorentz transformation, you get the same laws of physics. When I was in elementary school, people told me Einstein believed everything is relative. They made him sound like a hippie. And then I didn't like it, frankly. There was a time I was really against Einstein when I was a kid because these popular descriptions made him sound like a crazy hippie. But it turns out, no, it's hardcore realism. He says, yes, the laws of physics work in an absolute way in this coordinate system, but you get the same laws of physics if you rotate it. As long as you rotate it the right way, you can choose different coordinates. You can choose different north-south, and you can even choose slightly different future and past. You can rotate time into space and space into time. That's what a Lorentz transform does. And the first part of Einstein's theory was, okay, our universe is invariant with respect to a Lorentz transform until you get to gravity. And then we go to the slightly more advanced slide. Okay. So this is a little bit more precise. Our cosmos is basically just a set of continuous mathematical functions. This is my definition. Mathematical functions defined over the 4-dimensional space defined by x0, x1, x2, and x3. Those 4 numbers combined can be considered to be a vector. That isn't changing the assumption. It's just a different way of packaging the numbers so you can do math. And if you want to be like Einstein, you better learn how to do math. You don't just talk about the numbers, you learn how to work with them. And to do that, you just package them together. It doesn't change the assumption, but the idea is x0, x1, x2, and x3. You can think of these 4 numbers as a vector. This vector is just a mathematical object. It means 4 numbers crammed together. And we write it as x sub mu, where mu is 0, 1, 2, and 3. So u ranges over 0, 1, 2, and 3. Gravity, if you want one equation for Einstein, I didn't know which equation I should pick because he had a lot. On this page, I show you what may be his 2 most important equations. And it's not E equals mc squared. That's famous, but that's not his assumption that gave him the power. That was just a consequence at the end of the theory. The 2 most important equations of Einstein are this one. R mu nu equals T u nu. If you take a course in general relativity on gravity, they'll tell you the whole course is in this equation. If you understand this equation, you understand general relativity. This is the law of gravity according to Albert Einstein. And what this says, it basically says the energy out there drives the curvature of the universe. But the point is, this is equation you use in mathematics to solve for something called G mu nu, which is called the metric tensor. G mu nu. So it connects 2 dimensions. It shows how much they're connected. And when we talk about bending space, what it means is you're changing G mu nu. By using energy, you can bend space. That's basically what general relativity says in a nutshell. And of course, there are whole books on explaining what this sentence means. So now let me go on. HCER, hardcore Einstein realism, is not one theory exactly. It's a family of theories. It's a family of models. To get a specific model in this theory, in order to say how the universe works, there are two pieces of information we must add. If you believe in HCER, you will understand exactly how the universe works if you have these two additional pieces of information. You need to know N, which is the number of mathematical fields which exists in our cosmos. Do we assume there are 16 fields out there or 100? It makes a difference. So you need to know how many fields there are. And you may consider these fields to form a vector, phi of x sub mu. And if you know what this vector, phi of x sub mu, is at all points in space-time, you know everything. You know the whole history of the past and the future everywhere. If you know what the value is of this function, phi of x sub mu, you know everything according to HCER. And then I got to put in a caveat, because when I say there are n fields, a good physicist would say it's not really one vector. This is a mathematical vector. And in mathematics, they use the word vector to mean one thing. In physics, it means something slightly different in general relativity. And we have language problems in mathematics and physics all the time. So when I say they form a vector, it's a bunch of numbers. Mathematicians know what I mean. The concept of a vector is well defined. This is not bullshit. So HCR is well defined in terms of mathematics. But in general relativity, they would say we use the word vector to represent something special. It's a collection of four numbers like x mu nu. It's a collection of four numbers with certain properties. And the actual vector in an Einsteinian theory, it might be one vector, it might be a matrix, it might be 15 scalars. So you've got a finite number of components, and these components may be organized according to things that physicists call covariant vectors and tensors and whatnot. But it's still n mathematical fields, really. They're just combined in groups. Okay, so to specify how the universe works, you need to know what n is, and it would help you to know what the structure is of these fields, how they connect to each other, which are cousins. And now here's the most important part. In HCER, to specify a theory of the universe, you must specify what's called a Lagrangian energy density function. And this is the slide, this is the equation I used on the first slide. It's called a Lagrangian energy density. This is incredibly important. When you know the Lagrangian, you know everything. When I went to school, there were physicists who said, I want to know how the universe works. That means I want to know what is the true Lagrangian. So people have spent their entire life, not only in classical physics, but even in quantum mechanics. They have spent their whole life saying, I want to know what is the true Lagrangian of the universe. That is the real job of physics, to try to find out what is the true Lagrangian of the universe. And then the final bottom line, to complete the definition of HCER, to complete the definition of what it is, there's this final assumption. HCER assumes that these fields, phi, obey the classic Lagrange-Euler equations for whatever Lagrangian you choose. Once you know the true Lagrangian, you can insert it into these things called Lagrange-Euler equations, and those give you the dynamic law that governs all change and all fluctuations in our universe. And if I had a lot of slides, well, why? Maybe I should write down the Lagrange-Euler equations, but they're in any textbook. Once you know the Lagrangian, you know how the universe works if you believe. And I need to show just one more slide, because do you believe this? I have defined what HCER is, but there's some comments I should make about whether we believe it or not. So let me go to the next slide. Comments. In his later life, Einstein did not really believe that HCR was the whole truth. He did not believe that general relativity was a perfect description of how to bend space, of geometry. And in the later part of his life, Einstein hoped for a certain kind of unified field theory. Sometimes I wonder how many people on Earth ever read what Einstein wrote about unified field theory. I did. Sometimes I think there may be only 10 people alive today on Earth who ever read what Einstein wrote about unified field theory. What he wrote is very different from what creative writers say in history books. I actually read what he wrote on unified field theory. Some of it, if you really want to find out, look for things joint authored by Einstein and Infeld. Infeld and Einstein worked on it. Einstein hoped for a different theory to unify gravity and other forces into a purely geometric theory. And in his lifetime, he did not succeed. He spent years and years looking for a certain kind of theory. He never found it. But here's my caveat. If HCER is not true, the best alternative fitting the evidence we have at the far frontiers, the best possible improvement that I see would be based on what Einstein was working on at the end of his life. And I don't have time to talk about it, but I have seen some evidence that in the later part of his life, Einstein was on to concepts. And there are 2 or 3 people alive today who have developed those concepts further. And there is evidence they might do better in explaining basic physics than HCER does. But that's at an early stage, and there are very few people like that. And I'm probably one of the few people who even knows where they are. They're certainly not famous people, either one of them. The 2 that are best in that. So bottom line is, Einstein was not proposing HCER as the ultimate theory. He wanted to develop a new theory, but he never did. And so far as I know, HCR is the best theory. It encompasses everything we have evidence for. But yeah, who knows? Someday there might be something better. The next line is, when was gravity united with other forces? What I call HCER, it isn't really Einstein's position. What I'm proposing as HCER, this is part of my definition. I'm proposing that we should unify gravity with the other forces by using an idea which came from John Wheeler of Princeton. And John Wheeler was very close to Einstein. And Wheeler saw long before Einstein died, he saw there is another way to unify gravity with electromagnetism. He developed a theory, and he didn't want to upset Einstein. You know, getting Einstein mad at you, there might be a problem if you get Einstein mad at you and you're working in that field at Princeton. But John Wheeler developed something called an already unified field theory. And John Wheeler is very important. His already unified field theory only combined with electromagnetism, good enough to get a Nobel Prize, but the most general form of it. Wheeler's idea was extended by someone called Moshe Carmeli, whom you've never heard of. But Moshe Carmeli has a book called Classical Fields, which describes exactly how to unify gravity and electromagnetism in the spirit of John Wheeler. So when I define HCR, I am referring to Moshe Carmeli's equations for how to unify gravity and metrics with a Lagrangian model underneath. And finally, the last thing I can say about HCR for now, I may well be the only person on Earth who really understands the basic principles of quantum field theories today. I should have said alive today, and who also believes HCER. I first believed in hardcore Einstein realism for just 5 years. I didn't believe relativity when all I read was all these crazy populist nonsense. But in 1963, I was taking courses at Princeton. And in the mathematics weekly T, one of the Princeton faculty, explained to me what real relativity was, about Lorentz invariance, about symmetry, what I'm calling HCER. I learned what it is from this Princeton professor over tea. It was not in a class. I learned it while we were sitting in big leather couches having tea. And I believed in HCER until March 1967. And in March 1967, I had a personal experience. You call it a psychic experience, and I talk about it in detail on my webpage. And that experience just blew my mind. It was very hard for me to accept, oh my God, reality is not what I thought. And after that experience, I wondered, what the hell is going on? How can I reconcile my personal experience? Originally just psychic experience, but it expanded. How can I reconcile my personal experience with what I believe in physics? I was finally able to reconcile these things completely only in 2020. 2020 vision. I finally learned to see. It took many years and a lot of mathematics to learn how to unify and connect and reconcile these things. And it's the reconciliation, the connection, getting past the contradictions. That was critical for me. And I sure hope I'm not the only one who ever understands how these things fit together. It's really critical. Well, maybe Jeshua will be the only other one. Maybe Jeshua and I don't know. So that is pretty much it. I only have one more slide if anybody wants to talk about it, because Einstein realism is only one of the four crucial ideas that we need to understand. We cannot integrate, we cannot make sense of reality and spirit unless we understand all four and connect them. And it probably took all day and maybe more to do the first of the four. But the second of the four is also important. And in physics, it is equally important. They call it multiverse physics. This is the most plausible mainstream theory of everything. And until last year, I believed this might be the truth. If you go to my webpage, you'll see that in 2019, I published papers about reality. And basically, I was 50-50. Was Einstein right? Or was David Deutsch right? I felt 50-50 because there are good reasons to believe either one. And I also said, well, I said 30%, 30%, and 40%, it must be something crazy I didn't think of. Okay? Because there's evidence against both theories. Most physicists will tell you the evidence against Einstein is overwhelming today. But the same thing is true with Deutsch. So what the hell could the truth be? In 2020, I understand what the truth is, how you can do it from Einstein's viewpoint. But for many years, well, from 2009 until 2010, I seriously believed that David Deutsch's theory of reality with some modifications is the true law of everything. And when I say Everett, Wheeler, Deutsch, these 4 points of view, I claim that I produced the modification that makes it consistent, to be honest. It was not consistent internally until you made some mathematical modifications, which I made and published. But there are 4 generations of multiverse theory, and Deutsch was generation 3. Before him, there was Wheeler himself and Everett, who worked with Wheeler. And this theory of the universe is that we live in something called a Fock space. Space and time. This is the equation of the universe, according to David Deutsch's physics. And all 4 of these theories all make the same assumption. They assume that our universe is a dynamical system governed by this one equation. This is the law of everything. But with Einstein, you had to know what L was. With Deutsch, you got to know what H is. And there are a lot of choices for H. So with Einstein, there are a lot of choices for the Lagrangian. With this theory, there are a lot of choices for the Hamiltonian H. You got to know how many fields there are. It's the same kind of problem. But the bottom line is, this is the dynamic law of the universe. And at any time, we live in a universe defined by a wave function psi. The state of the universe is defined by knowing the value of the wave function psi across all points x and t. But x is no longer three-dimensional space. That's the change. In the Einsteinian theory, x would be a three-dimensional vector. You could call it xt until you rotate it. In this theory, you don't rotate it. You lose the rotation. There's no rotation here. You kind of lose some of Einstein's ideas. Einstein didn't like that. You have the state of the cosmos, the space-time, is a wave function defined over x, which is a point in Fock space, what's called 3D Fock space and ordinary time. And Einstein was pissed. You can't say space and time work differently. Doesn't look like that. Well, according to this theory, they do. And this theory works. This theory fits all empirical physics, the best of any theory ever developed by humanity, except maybe a few little things that I think need Einstein. In fact, a few little things in Yeshua's laboratory, which may require Einstein. But the bottom line is, the wave function is viewed as a concatenation of wave functions. You've got a component which is a mere 3 dimensions plus integer variables, and another component which is in 6 dimensions. It's a connection of an infinite number of dimensions, and they call it the multiverse. And the idea is we live in a multiverse. There are parallel realities. There's a version of you in this stream of the multiverse. What we call the universe is just one point of view, one narrow slice of a bigger cosmos. So in the multiverse theory, we live in a gigantic cosmos. And it's governed by this equation. This equation works. This is not just philosophy. This is the equation David Deutsch used to invent something called the quantum Turing machine. And David Deutsch's quantum Turing machine is the basis of all quantum information science in the United States today, at least funded by the government. What we call quantum computers are actually quantum Turing machines. There are more advanced kinds of quantum computers, which a few other people develop. So anyway, those are my slides. I apologize for so much time, but you've seen the slides. There's a lot to talk about. Where would you like to go from here? It's totally up to you.
At this point, we often ask, go around and ask each person for their takeaways. We could do that. I'm mindful that we have 5 minutes left at the top of the hour. So if there's anyone who needs to leave soon or has been staying up since when it's now like 2:30 in the morning.
Let me insert a caveat, by the way. I have been recording so far. As soon as one of you tells me to stop recording, I will stop recording. And don't be embarrassed. If you need me to do that to talk, that's fine.
So Paul, I'll start off. Very interesting. So, I mean, I'm also following a similar, different but similar thread in a different group. Can you talk a little bit about information passing between different? Well, I have several concerns. One concern is that as agents within the system that we are somehow imbued with an ability to understand the system of which we are a component. I struggle with that. So the idea that an agent within some system can comprehend the system outside of themselves and speak for other agents in the system who have a different interpretation is very antithetical and kind of comes from a very different position than unified and an integrated model. Nowhere
That's already something I should comment on.
Okay, go ahead.
Okay. This is a very fundamental question you're asking, and I'm glad you asked it because it is so fundamental. And in order to understand this stuff, I had to articulate and face up to a lot of paradoxes. When I look at academia today, a lot of people are held back by paradoxes, and they must be articulated first before you can resolve them. And so I thank you for articulating it. Way back at the time of Isaac Newton, I believe there were people who felt you could never have something like a laws of physics. The whole idea seemed alien and seemed impossible. And one of the greatest sources in those days was the work of Heraclitus, who said nothing stays the same. Everything changes. Nothing can be trusted except for the laws of change themselves. No, except for change itself. He said change itself, and Newton stood it on its head by creating a new way of thinking. And Newton made a lot of mistakes, like all of us, but his new way of thinking was we can understand the dynamic laws of a system. And you don't need to have brain space enough to hold the entire state of the system. You can learn a lot simply by knowing what the universal laws are. That doesn't tell you everything. You don't become a person who knows everything, but knowing the laws of the dynamics, that's really the principle we have been working with. And bottom line is, the more we learn how to apply that approach, the more it works. Our brains have evolved to be able to learn models, and we have learned through the years that we can build models which explain more and more and more. And if we ever reach the point where we can't explain more, where it doesn't fit, then we've got to change it. Of course, we have to be open to evidence. But after being open to evidence, my conclusion is I see no reason for changing the basic framework of Einstein realism. That means we don't yet know the Lagrangian. And there's a hell of a lot of emergent behavior we need to understand better. But right at the moment, there's every reason to believe that the belief in reality is consistent with all of the experience we have. It's not enough to tell us what to expect tomorrow. This is not a perfect guide to predicting political science, but it does give us the ability to predict psychology and movements better and better. We can do better in economics and political science if we are informed by a more true understanding of neuroscience, consciousness, the mind, game theory, and all of the rest of it. So my claim is the Western program, it's way too early to abandon it. We are still learning new things, and there is nothing which does not fit this program that I know of, even when we carry it all the way to trying to understand the soul. I see nothing that violates the basic program. A lot that needs to be filled in, but I don't see anything that violates the program.
So one more very quick point, and you don't have to respond to it because I do want to allow everyone else. But the other struggle I have with this is determinism. So there is a tension between the idea of free will or agents having the ability to actually make substantive change in their world versus a deterministic system where we're just essentially deluding ourselves that we have this thing called free will. So if we have perfect mathematical models that have perfect predictive power, it means that free will is an illusion and everything is completely deterministic. I don't actually believe in that. And I think that information can, I think that the system itself is alive. It's not a dead set of equations. So I struggle with the idea of perfect systems in general, because perfect systems essentially deny entropy. They deny the system having information being created in a constant fashion. We create the universe at one point in time, or the multiverse at one point in time. We set a bunch of parameters to an initial starting condition, and the rest is deterministic, and no new information can emerge in the system. That's not what quantum foam is. I understand that, but the formulation of these theories as being independent of time and independent of new information, I don't buy it. And that's just a personal thing.
Okay,
I
no,
think that
I need to explain what the paradigm is a bit better. And one of the
And
big problems.
once you Paul, you tell, I would like to inject some thoughts to this. So,
Of
but
course.
go ahead.
go ahead, Robert.
Me? I
Sure.
thought I don't want to sorry interrupt Paul, but okay. All right. So maybe just very briefly. Okay. Sorry, my wisdom tooth was just removed, so that's why I'm maybe not very.
My God, we must be on the same frequency. I had a
Okay.
major tooth operation
Okay.
on Thursday.
Alright, so
Okay.
okay. Anyway, so I take off my video just for that. Okay. Right. So I think that what David, you just mentioned about the determinism and stochastic, that is one question, you know, Paul introduced me. We worked for 20, 30 years, and that is one issue we actually permanently debate. And I don't go into details, but maybe just tell you the following. So maybe Paul more on the deterministic side, and I more agree the way, David, you posed that there should be a space for the stochastic aspect. But maybe I just say one additional thing is that actually what Paul at the beginning mentioned, that you cannot just polarize the two opposites. That is exactly valid for this as well. So I think that saying that that either deterministic or stochastic, actually it is such a polarization. So what we are addressing here, it includes both. And I understand that that it sounds self-contradictory, but it's really, maybe just before I stop, one way to put it, that there are theories that any deterministic system can be approximated by stochastic system with arbitrary accuracy, and vice versa. I mean, one way it is clear, the other way it's a mathematical theory. So so I think we need to be very careful, certainly when saying that deterministic systems are the only one, because the real mathematical models are much more complicated.
Yeah, so actually it's easier for me to respond to Robert and then maybe come back, because this is a very clear distinction. If we want to model our cosmos as a dynamical system for openers, should it be a stochastic model or a deterministic model? And most of what they show you in quantum mechanics looks kind of stochastic these days. There are a lot of probabilities out there. And it turns out Einstein said to his friend, John von Neumann, God does not throw dice with the universe. John von Neumann studied dice. When I mentioned the theory of games and economic behavior as my Bible, if you look at that book, you'll see more probabilities in dice than you will anywhere. When it comes to my personal life, this highest level of aggregation, when we get to the highest level, I often cite Rafa in neural networks. I often cite Rafa, who translates von Neumann into English and into probabilities and subjective probability estimates. But the interesting thing is, when Einstein said God does not throw dice with the universe, at some level, John von Neumann just laughed at that. And I just laughed at that. I have considered many possible alternative models. In fact, in the world of quantum optics, Carmichael, who Yeshua is working with, Carmichael's books on quantum optics describe the statistics and probability theory and the entropy functions, which apply in real quantum optics, not in bullshit, in real stuff. In describing those statistics and probabilities, They describe several mathematical mappings which go back and forth between mixtures of possible values of classical fields and the quantum representations of density functions, which are inherently stochastic. One of those mappings is called the Q mapping. And I even have a paper up in arXiv, if you go to arXiv, on the Q mapping. And I seriously considered, if we use Carmichael's Q mapping, can we improve our understanding of physics? And I was hoping the use of a stochastic model could predict things different from what Einstein's model would predict, something we could test, something we could justify. I looked very hard at that. I believe in probabilities in principle, but I see no empirical evidence whatsoever for them in practice at that level of reality. At the emergent level of reality, we see lots of probabilities. When we look at the Bellman equation or the Boltzmann equation of thermodynamics, we have lots of probabilities in the entropy equation. That equation I showed you from John von Neumann on my very first slide, I just picked an equation out at random. It turned out to be one of those probability equations for the stochastic, how the probabilities evolve for certain classes of dynamical systems. And von Neumann worked out the entropy equation for many systems. I worked out the entropy equation for a few others. Entropy is very important. Stochastic effects are important at our level of life, but that doesn't say that the underlying laws of physics include dice. So at the deep level, there are a lot of dice. Maybe if I talk more about the higher levels, you would be happier, because all I talked about now was the underlying physics. If the underlying physics does not have dice, why do we feel as if we have dice at our level of existence? And the point is, that is an emergent phenomenon. It is an emergent phenomenon that brains and creatures evolve who experience the universe as something uncertain because their knowledge is incomplete.
Thank you. I'll pass the talking stick to someone else.
Let me try David's question a slightly different way. How does free will emerge?
Okay. I like to believe that's something I really know about. Because when we talk about free will, we are talking about the mathematics of mind. And the mathematics of mind is that coherent stream of thought coming from von Neumann, which I have spent most of my life working on with Yeshua and Robert, collaborating a lot on that. In the paper by Yeshua and Werbos, we review what is really known in neuroscience. And the truth is, most people in neuroscience aren't doing cognitive neuroscience. They aren't studying what is the connection between our brain and our cognition and our feelings. But there are a few of us who have worked with cognitive neuroscience, including Robert, Yeshua, me, and a few others. We have worked also with people called Walter Freeman and Carl Pribram. My last talk before this group, I talked about those people. They studied the phenomenon of will and emotion in human brains more than anyone else on earth ever did. And their concept is different from the behaviorist neuroscience. Behaviorist neuroscientists model human brains as if it was a cloud, just no free will or motivation at all. But you don't have free will unless you have will. The starting point for this phenomenon we call will, before free will, there has to be will. And before will, there has to be what we call telos or purpose. And the claim is that purpose, a sense of telos, primary motivation, evolves in biology basically brains that have a sense of purpose have a better chance of achieving their purpose. You are more likely to survive in nature if you're trying to survive. You're more likely to survive in nature if biology endows you with primary reinforcement emotions, if nature endows you with a preference for some states of the world over others. And those are very deep. Those exist all the way down at the level of fish. There are things which make fish unhappy and in pain. This is part of our inheritance as vertebrate brains. And I would claim they're also part of our soul, because I claim even our noosphere has an intelligence or mind. And so the utility functions are part of the very foundation. Utility functions, the theory of games and economic behavior, gives us a motive. Where free will comes from, the illusion of free will, is that we as intelligent creatures, part of what our intelligence is trying to decide how to act. We are evolved to try to learn how to act. That means we are evolved to exploit a sense of choices. That's part of how our brains were evolved. You could call it an illusion, but it's not exactly an illusion. It's a critical part of how our brain works. We are evolved to try to learn how to take advantage of our choices, how to be aware of our choices. Our sense of free will is an act of awareness. It's an act of awareness where we become aware of what the real choices are before us. And the more aware we are of the choices we face, the better we can be at making choices which maximize our utility in the long term.
Yeah, all that makes sense, sort of. But does that mean that there has to be some inherent source of randomness in, in the HC framework?
That's a fun question. I thought you were going to ask something else. Is there a source of randomness in our free will?
I mean, at some level, it would seem that if you didn't have that, the capacity for evolution, for free will might not arise.
Forgive me if I give you a cheap shot, okay? Since I've studied brains, and we've got Robert here, Yeshua even might be able to see this someday. There are levels and levels of intelligence. Every time I run across a philosopher who says, is this conscious or is it not? Does it have a mind or does it not? I want to vomit, because in reality, there are levels and levels of intelligence, and they are a little different. And the answers are sometimes different as you go up the levels of intelligence. And the mouse or the rat has a mammal brain, and that is at a higher level than the reptile kind of brain it evolved from. And the mammal brain is a magnificent step forward in evolution related to your question. Okay? They're qualitative studies on how mammal brains are different from lower brains. And based on some of my papers, which I cite in Werbos, and Davis cites an earlier paper in the journal Neural Networks, I explain the 6-layer cortex of the mammal brain as a fusion of 2 3-level cortices which existed in lower brains. One of these lower cortex maps out the space you live in. Even a fish needs a mapping of the space it lives in based on its vision. And then there was another cortex, which reptiles have at least, which decides on an action plan. I even once had a slide that put somebody like Cheney up there under the dinosaur saying, this guy is decisive. He can make decisions. He has the kind of cortex which lets him formulate a decision and act on it. But what the mammal does is it unifies the decisions with the mapping, so that mammal brains have a unique ability to map out the space of possibilities, the space of possible decisions and actions. And the fact that we map out the space of possibilities is a very important part of how we survive. And part of our human, well, our mammal sense of free will is because we have a mammal level intelligence, we can see possible decisions, possible paths, and we have a map in our brains of possible decisions and where they might lead. And that mapping of possibilities that we choose between, that has a lot to do with this sense of free will that we have as mammals.
Yeah, okay, so I could chime in. I don't know if we want to continue this topic or we move on, but if you don't mind, I try to be brief.
Sure.
Okay, so, all right, so just about this free will and how this mathematical equation, what Paul showed, which seemed deterministic, how to can accommodate for that. Okay, so for the free, I just tell you that in the 90s when I was in Berkeley, of course, with Walter, then we actually attended, I mean, Ben Libet gave talks, of course, so I understand a lot about this cognitive aspects, about this paradox and so on. But what I think it's very important, and that whatever, and that is goes a little bit broader. So whatever is the equation, okay, even if it is assume is a deterministic equation, but I am just telling you from a mathematical point of view that there is at least some mathematical theories that deterministic and stochastic have some very intimate relationship. But even beyond that, I think it's a very important view is that any model, doesn't matter deterministic or stochastic, is just a model. So it's really the world and our brain and so on is always beyond any particular model. That's what we call science. So when we have a certain model, that's it has its limitation, definitions and so on. So you always go beyond that. So in that context, just keeping in mind that the reality is exceeds any model. So I don't just want to wipe away this potential danger, but I just want to point out that there is always a space behind.
Yeah, and perhaps I should go a little further. The basic principle.
Paul, let me know when can I intervene when you're finished, okay?
Okay, yeah, because I do want to respond. The key point I wanted to make in the very beginning, I believe with Einstein that the underlying laws of physics do not include dice, just because we have no evidence for dice. I've looked for them. I'll be happy if we find them. I see no evidence, but that's for the underlying laws of physics. And the belief is that there are absolute underlying laws. But then there is this program of von Neumann. And I try to channel the spirit of von Neumann as much as I can. And what von Neumann said was, when we use mathematics to understand life and mind, I would take this further. The mathematics which connects from basic physics to life and mind, it is the mathematics of approximation. It is a great chain of approximations. There is an exact equation for what exists in our universe, actually. In a way, life is really just governed by the emergent equation, which is called the grand canonical Boltzmann probability density operator. And that's true exactly if David Deutsch is right. If David Deutsch is right, all life in the universe is contained in that equation, But the problem is it's a very complicated equation and you don't know what it's telling you unless you learn to approximate it. So all the models we actually have, that we actually use for life and for mind, all of the models we actually use to engage with the brain, let alone political behavior, all of these are approximations. And no matter how good our models get, they are always approximations. When I was building good neural network models, I knew control theorists who had said, we want to solve this optimal control problem exactly. And I said, no, you can't. We have a good approximation method. It's one thing to have a good approximation. It's another thing to pretend you have exact knowledge. So the mathematics which connects physics to life and mind is the mathematics of approximation. It is a great chain of approximations, and von Neumann spent a whole lot of effort on how to improve our approximations and structure them and organize them. In a way, that's what mind is all about, is approximating our understanding of life. But now, Yeshua.
Since this talk was about the connection between physics and soul, I would like to connect them with very simple little, ideas. But I remember an old wise man, an ancient wise man called Yeshua ben Yosef said, if you had faith even as small as a mustard seed or something like that, you could say to the tree, be uprooted, and it would happen. Now, I want you to hear that statement from the point of view of Howard Reifa, John von Neumann, and Ronnie Howard from Stanford. If you had faith even as small as a mustard seed, there is a concept in decision analysis which is called perfect information. And when you search for perfect information via market research or a shaman or a magician or even God, what you're doing is minimizing uncertainty. So the whole point of minimizing uncertainty is that you approximate that curve. You never reach total certainty on the plane of human beings. You always have a probability that things will not go the way you thought they would, and that's the approximation. So that's one idea, that perfect information is something we can approximate but never reach. Only if we had perfect information, then we could talk about the deterministic world. But that will be the world of a creator which transcends us, even though we could say like Spinoza, it's immanent, but that mind transcends our mind. So for us, that perfect information, it's only a process of approximation. Then the other thing that I wanted to say, which is a very simple example of what Robert and Paul were talking about, the coexistence between deterministic models and stochastic models, is basically that every single one of our simulation models on Earth are grounded on random number generators. And everyone who understands random number generators knows that these are deterministic sequences with long cycles which appear to be random. They appear to be random so much that if you pass a test to them in any form of distribution, you get a test like a Kolmogorov-Smirnov or a chi-square test past the test of randomness. But actually it's a deterministic formula. It's the modulus. I mean, it's a very simple formula. So you have an emergent property, which is randomness, in a random number generator already there. And so we have this thing there, so we have one thing is the approximation to perfect information. The other thing is that randomness, it's already embedded in a deterministic model. And the other thing that I wanted to tell you, to share with the group, it was that when I think about physics, and Paul and I and Robert have talked a lot about this, and I don't think that physics holds mathematically the full explanation of reality from the point of view of the transcendent mind, from the point of view of God, but it holds the explanation, potentially an explanation of reality, which will be greater and greater as our minds approach the transcendent mind. As our mind grows and our spirit grows and our soul develops, then our models of reality will be much more comprehensive. And so I think that this is where a model which is just a description of reality, in the best case, an homomorphism, it's going to happen only, an improvement of those models is going to happen as we grow in our consciousness, in our understanding of our being and our potential connection with noospheres, or the sphere of mind, or even the mind of the creator. And that's something that I wanted to share, just to leave those ideas, which I think somehow join the physics with the soul.
They do
All right.
indeed. Thank you. That's very, very insightful. Thank you. Yes. Interesting. Anyone else? Any other? So I just wanted to kind of throw out one last little kind of challenge, which is the challenge of new information, or the model actually changing. So many mathematical models attempt to describe systems from the idea that there is some initial state, and then there is a complete and coherent and comprehensive set of parameters that define and allow the system to essentially unfold. Is there a possibility that new information can emerge after the creation event? In other words, can the rules of the system change, or even be changed by the system itself? Or is the system itself trapped within this kind of ontological argument of, well, that there's just this, you're just talking about a special case of a system that's within a more general system. So this is kind of the inductive generality argument. Can we create new information? Can the system itself evolve? Or is it completely, deterministic is the wrong word, but unchanging in the sense that no action that we can take within the system can actually change the fundamental laws which guide it? And that's an open, I'm not asking you to respond to that, but that's
No, that feeds beautifully into some of the things we've studied. The role of time is very important. I sometimes say even poor Einstein allowed himself to be just a little bit schizophrenic in his attitude towards time. Because one day he said time is just another dimension, and another day he made a personal prediction for an experiment he proposed, which assumed that, of course, time is flowing forwards and time is fundamentally different from other dimensions. He made one assumption in his subconscious mind when he made a visible prediction, but his math said something different. And it has to do with how time works. When I defined hardcore Einstein realism, I didn't include Einstein's intuition about time being forwards only. That was a later intuition. That wasn't in his math. I only gave you his math. It turns out Einstein's intuition contradicted experiment. He proposed an experiment called the Einstein-Podolsky-Rosen experiment, which was very famous. And they renamed it the Bell's experiment because there's a nice guy named Bell they like. He was politically correct. But the actual experiment was proposed by a classmate of mine, Clauser, Holt, Shimoni, and Horn, described in a book by Bell. But the bottom line is that experiment thoroughly disproved Einstein's ideas, intuitive ideas about time, which led him to predict that experiment. So when I say I believe in hardcore Einstein realism, I don't mean that bad prediction he made. Instead, I mean the theoretical assumption that time is just another dimension. And if you believe that time is just another dimension, and you work out the statistics using mathematics rather than knee-jerk common sense, the mathematics predicts we have to change our model of measurement. And that applies to quantum theory just as much as it does to classical physics. And so on this slide, Everett Wheeler Deutsch, MQFT, all of us agree that these are the dynamic laws of the universe. Well, I don't believe that this is the ultimate truth, but MQFT, that's my version of this. I would say this is a pretty good model, despite some limitations. What's wrong about the old version is they assumed measurement operates forwards in time only. That's inconsistent with this equation. The equation is symmetric with respect to time. And if you predict that your measurement device is inconsistent, that's an inconsistency. So I have proposed a different model of the macroscopic objects that you use in a quantum experiment. This is not about the basic laws of physics. This is about the models of macroscopic objects to go with the theory. And if you change those models, if you modify those models, you get different predictions, and they are testable. And the key prediction is what you think are the initial conditions can be changed because of later events. And if you
okay.
believe in the multiverse theory basically says an action which you take later can change your initial conditions. And there is experimental reason to believe that sort of thing. And that's why I believed in this for a while. But it turns out the Einstein framework is more powerful than I thought. Those Lagrange-Euler equations are smarter than I used to think. Those Lagrange-Euler equations are not so stupid as people imagine. It's like chaos theory. People used to think that ordinary differential equations could only generate trivial behavior. And they learned about all this strange stuff like chaos and whatnot. If you understand the equations better, you'll understand they contain a lot of intelligence. And when Yeshua talks about the creator, I think of the cosmos, and I think of Lagrange-Euler equations, because I think they're very smart. If you really understood those equations are smart all by themselves, and they produce all kinds of effects that sound counterintuitive until you understand the equations a little better.
Jeffrey Milstein would like to make a comment.
Sure. Hi, Jeff.
Hi. I did have a comment about Paul mentioned in his presentation about the utility maximization. The philosopher of science, Jay Bernowski, wrote that the purpose of science is to allow us to look ahead so that we could choose the actions that produce the results that best maximize our rewards and minimize our punishments. And if you're trying to choose a theory, I suggest that you also need to consider the social impact of the theory, the social impact. Take Einstein's own E equals mc squared. It led to the atomic bomb. In fact, Einstein's letter to Franklin Delano Roosevelt was the initial letter that touched off the Manhattan Project. So I suggest that if we're trying to minimize our punishments and maximize our rewards, we need to think about the social impacts of the theories that we adopt and use. Thank you.
Yeah, very good point.
Yeah. And let me say this is certain. Well, maybe Yeshua should respond.
Yeah. Okay. So I think that's a very explored point by Paul and Robert and I and Walter Freeman, who is now it's in a better life. But and the basic thing that motivated me to write a master's thesis in New Zealand, which was exactly that, was to try to explain how the brain of a prophet or an enlightened person or a mystic or a prophetess works. And what are the transformations in the brain that have to take place so that the person changes so radically perception of reality, as Paul was describing when he has his psychic or mystical experiences or psychic experiences. What are the processes? And so there was a fundamental reality that it's not measurable, but it's fundamental to us human beings, which were values, and they are part of decision analysis. When we study decision analysis, we study value-based decision making, and so the utility function can have a variable which are your values or whatever you consider it's meaningful to you. So this is part of the brain dynamics of Walter Freeman, the creation of meaning in the brain. So I'm giving you just a very brief introduction of these elements of what I want to tell you. What I want to say is that for me, the fundamental reality of the universe are values. And Paul was touching on Aristotle and substance, but values like love, values like truth, like unity, like humor, they are values that are not behavioral values. They are spiritual values or universal values, and I would call them part of a value field. So when Paul is describing the five function there in the Lagrangian, one of the fields that I introduced in that master's thesis, which was kind of a real shock in university, I mean, in cognitive neuroscience, it was that the value field was actually a real field that we couldn't measure, but it modulates change in behavior. And it modulates change in behavior by the inner transformation of the individual and its mind, and therefore the brain. And so when we talk about social theories and the social implications of our research, I had in mind, and these are discussions that I had with Paul and Robert, more dialogues than discussions, but very rich dialogues, that our purpose as scientists shouldn't just be to try to minimize reward or punishment and maximize pleasure, but it should be, as a scientist, it should be do no harm, like the doctors, and also what it means to be an embodiment of these universal values. And therefore science, a value-based science, which is it's just a heresy sometimes to speak, or was to speak about that. It's actually what will frame what your concern is, that our theories and our descriptions of the universe will incorporate elements which are benevolent and constructive, and that allow to overcome entropy and chaos, and not chaos in the mathematical sense, but entropy and degenerative processes for the psyche, the soul, and the human being and society. And so I think those are elements that come with integrity. And Paul was saying before, integrate or disintegrate. Well, integrity has to do with that. And some of the concepts that Paul has mentioned in his papers, which are very powerful, I think, are the concept of first order sanity and second order sanity. And just to give you a very simple example, first order sanity: you shall not kill, you shall not steal, you shall not lie. If these three principles, which are 3,000 years old, more or less, would be applied, and every human being would commit, the budget of humanity would be reduced by probably 80%, in what it means, security and contracts and all sorts of things. And that's first order sanity. But when you go to second order sanity, which is asymptotical, you go to a more deep understanding of reality and benevolence and love. So you just don't kill because there are consequences, but you just don't kill because you love your neighbor. And so those principles I integrated in cognitive neuroscience and physics, even though they cannot be measured. And I did that through system thinking and systems theory, and the understanding that there are soft variables like subjective probabilities in decision analysis. There are soft variables in the dynamical system which modulate somehow the emergence in the behavior of the more quantifiable variables of the system. So, there was a question before, are we trapped in the system? That was a question more or less I heard. I think it's not that we're trapped in the system, but sometimes we have a glimpse, or we have an injection of, let's call it negentropy or anti-entropy or centropy from a spiritual value field that overrides the laws of nature occasionally. If we accept the possibility, for example, that Moses or other prophets or Buddha entered into those states where reality could be transformed, but it wasn't the mind of the human. It was the transcendent mind becoming one and immanent in the world for periods of time in limited brains that allow those transformations. So if you allow that openness in the system, if we allow that we're to be an open system to the greater universe and the greater mind, then there are glimpses of that mind that will override entropy and will create new beginnings, renaissance and order out of chaos. And so I think your question is relevant because if we allow ourselves, if all of us allow ourselves to channel those values, to embody those values, then our science will produce theories which will not end up in atomic bombs, I think.
Very good.
Yeah, there is more to be said yet. I hope you don't mind. There's a lot to be said about these issues. As a caveat, I should say, Yeshua and I have known each other for a long, long time. And we've had formal, serious conversations and relaxed, informal, almost joking conversations. And I remember one conversation where I said, we are both trying to respond to higher spiritual forces. But just as Carl Jung might say, some people are channeling one archetype, some people channel another. When I worked at NSF, I had a colleague who I thought of as the incarnation of Loki. He was a hell of a guy to work with. And he had something to contribute, but God help us if you don't keep Loki on a leash. And in my conversations with Yeshua, there was a time when it seemed like most of my life, I have been trying to act as kind of an avatar of truth. And Yeshua has been trying to act as an avatar of love. And we really believe these principles, love and truth, are very, very fundamental. At the level of intelligent systems, like our brains or our noosphere, maybe this whole little cosmos you see on the bottom of this slide, intelligent systems, when you build them, there really are basically two metrics which drive the evolution of any intelligent system. One is the utility function, which is sort of where love comes into it, really. Creating, I mean, that's, you know, when you talk about the utility functions for a mother rat, it's not just the pain in her body, it's the feeling she has for her children, you know, and even rats can have affect. And in a way, if the female rat had enough foresight, she would realize she's dead in time. So this love is the main utility function of enduring importance to any rat that has a decent amount of foresight, okay? Is the love that you feel for that next creature, that next generation. And Doug says, hey, I know about that. We're talking about real human utility functions and feelings now. Yeah, that's reality. But there is also something called truth. There's a guy we knew called Perlovsky. Robert used to work with him a lot, and we met him a few times. He wrote a paper a lot of people loved on something like the knowledge instinct. And when you build an intelligent system, there is a thing called error and accuracy. And truth is a basic principle in the design of a brain. It has to learn the truth more and more. And so the spirit of truth is the one that I channel. And I better learn to be subordinate to the spirit of love, right? I got to learn a few things. But we need the spirit of truth more and more. And it could be that lack of truth, the problem is there's an age where too much truth can get you killed, like with atomic bombs. But there's an age when if you don't learn that truth, you get killed from not knowing. Our entire noosphere of this solar system is going through a period of transition. Our species is going through a very difficult transition. There are things we didn't need to know, which would have hurt us to know. And we may enter a period where if we don't learn, we may die from our ignorance. And this is the problem of transitions in life. This is an emergent phenomenon. Sometimes I tell people, if you try to picture our noosphere as a great female spirit, it's a good image, what the hell, you know. At least it's good for males to imagine the solar system as a great female spirit, you know, because help us remember our love for our noosphere. But don't think of our noosphere as an ancient crony like Gaia, who is all wise. Think of our noosphere as a teenage girl going through adolescence, incredible internal conflicts, maybe even about to have pregnancy, and she needs a little bit of help. Okay? That's sort of what our noosphere is going through. And part of that help is we got to learn to start knowing stuff we didn't know. Now, I would say how to make nuclear bombs is one of those things we don't want to talk about. Let me assure you, Jeff, I know a lot of things about how to build scary nuclear bombs, which I don't talk about. I'm very careful not to talk about the really scary things. But the stuff I think is safe sounds scary to a lot of other people. Like we got to know about computers. People say those are scary. They will be scary if we don't understand them, but we better understand the computers better. How to build better nuclear bombs? I don't want to talk about what Einstein came up with when he was older. There is scary stuff in that nuclear world, but I don't want to talk about that. We got enough to figure out without, you know, with these other things.
It's very challenging to bring this conversation to a close, but I think we should try. Mary Beth, should we kind of?
Sure. I will say that there's you can think of things as what, so what, and now what. And so we have looked at some what, we've looked at some so what, and hopefully we'll begin to think about what now what would look like.
Very good.
Yeah. Thank
Well,
you
it's a
all.
real pleasure to meet your friends, Paul. They're absolutely fascinating and very, very interesting people.